Okay guys, so let's proceed with the problem number 2. So before that, again, basahin muna ulit natin. So an aluminum tube 1.2 meter long has the semicircular cross-section shown in the figure. So if stress concentration at the corners are neglected, determine first the torque that causes maximum shearing stress of 40 megapascal, and for number 2, the corresponding angle of twist of the tube. So use the modules of rigidity for the aluminum as equals to 28 gigapascal. Okay, so guys, for this problem, as you may notice, magkaiba kasi yung value niya ng thickness. So para do sa semicircular part, or dito sa part na to, so the thickness is 2 mm. And dito sa may diameter niya, yung thickness nung ating tube is 3 mm. So, varying yung iyong value ng thickness. So, kung maaalala do sa discussion part, do sa lecture part ng inyong module or ng inyong workbook, yung formula natin kasi kay theta, ang sabi dyan, constant thickness. So, hindi ko dyan na-indicate kasi what if varying yung value ng thickness niya. So guys, this formula was only derived using this formula. So guys, paki-include na lang din ito sa inyong workbook. Pakisulat na lang that. So that is TL all over 4G times AO squared multiplied by the surface integral ds all over T. Okay? So, dito sa unang tanong, ayan, the torque that causes maximum shearing stress, wala namang problema dyan. Again, ang gagamitin lang nating formula is eto. Balikan ulit natin. So, etong para ay shear flow, where shear flow is equals to T over 2 multiply by A sub O. And eto, yung shearing stress, torsional shearing stress is equals to shear flow all over thickness. So, with that formula, makakompute natin yung pinapahanap, yung torque that causes maximum shearing stress of 40 megapascal. Okay? So guys, because the shear flow is constant in a prismatic tube, the maximum shearing stress will occur in the thinnest part of the wall. So kung hindi maniwala, pwede mo namang i-consider din yung thickest o yung mas maapal na thickness ng iyong tube. Okay? So, pero, I'm sure that yung maximum shearing stress will occur do sa thinnest thickness nung ating tube. Thinnest thickness. Okay? So, again, knowing that the formula for shear flow, di ba ang ating formula for shear flow is equals lang yan sa yung shearing stress or the torsional shearing stress multiplied by the thickness of the tube. Pero again, ang gagamitin nating thickness dyan is yung pinakamanipis. Okay? Or the thinnest. So that is equals to 40 megapascal. So again, that is 40. So that can be written also in Newton per millimeter squared. And then multiply by thickness. So again, yung 2 yung gagamitin natin. 2 mm. So with that, the answer will be, so 40, so may all cube. 40 times 2. Kinalki pa talaga. 40 times 2. Or that will be equals to 80 Newton per mm. Okay? So next, given yung formula for T, or the torque, so that is equals lang sa 2 multiplied by A sub O, and then multiply by the shear flow na Q. Okay? But, ano yung A sub O natin o yung cross-sectional area enclosed by the median line? So guys, as you may notice, yung atin namang radius is sinukat coming from the center hanggang sa gitna ng ating tube. Okay? So, or in short, ito is yung mean radius natin. So, Since that is the case, wala naman tayo magiging problema sa pag-compute ng kanyang enclosed area. So that is simply half lang ng circle or half lang ng area ng circle. Or yung a sub o natin is equals lang sa pi times 25 squared. So since kalahati nga yan, i-divide mo lang ng 2. And then multiply by the shear flow na 80 Newton per mm. So the value of our torque is equivalent lang saan? So kunin lang ulit natin yung calcu. So 2. So answer na natin para yung Q diretso times 2 times pwede natin cancel yung 2, di ba? So 80 times pi times 25 squared. So the answer will be equals lang sa ito. Teka lang ha. 157 07 lolo ko na naman 079.6327 079.6327. So this is in Newton mm. Okay, yung torque natin. Okay, so nasagot na naman natin yung unang tanong. So this is the answer for number 1. Okay, so how about for number 2? Again, ang ating equation or yung formula na gagamitin for number 2, since magkaiba lang yung thickness nila, so i-copy lang natin guys. Again, ano na lang ng formula lang yan. Or yung theta natin can be solved if varying yung kanyang thickness ng formula na theta is equals to TL all over 4G multiplied by A sub O squared times the surface integral of itong surface integral ngayon lang kami nagpangitin over ds over t. Ayan. Okay, so again, ayan po yung gagamitin nating formula. So the cross section consists of 2 parts. So ito, nilabel na naman niya sa figure. So yung part 1 for the semicircle and then yung second part is the yung sa may bandang diameter. Okay? Each having a constant thickness. Okay? Hence, we can write this equation. Etong surface integral, pwede mo siyang isulat as equals lang saan. Since dalawa nga yan, pwede mo kasing sabihin na equal siya sa surface integral. So, ito, i-label natin ng S sub 1 ng ds all over thickness nung iyong ito, yung part na to, which is 2 mm. So, plus the surface integral. So, ito naman is para dun sa S sub 2 natin. O, ano nga yung S natin? So, that is the median line or yung haba nito. And then, ito yung S sub 1 And then, yung S sub 2 is ito. Okay? So, ds all over t sub 2. Okay, so since constant nga yung ating thickness, pwede naman natin siyang i-factor out na. Or that can be written also as 1 over t1, the surface integral of ds, plus 1 over t2 times the surface integral sub 2 of ds. Okay? So if you're going to take the integral of that, so that will be equals lang sa S sub 1 over T1 plus S sub 2 over T2. Okay? So next, for S1 and S2 nga are the length of the median line for the part 1 and 2. Yun yung itong portion na to. Therefore, yung equation na yan, equals lang din siya saan? Itong ds over dt. So, inahin natin tong S sub 1. Ito, paano nga natin siya mako-compute? Using the equation or the figure. So, knowing that yung radius natin is 25. So, kalahati lang ng circumference, diba? Or that is 2 pi r over 2. Or that will be pi r na lang. Kasi dinivide mo na sa 2 yung circumference ng circle. Kasi kalahati lang yan. So, pi r. So, pi times 25 over yung thickness 1, which is 2. And then plus yung S2, or that is, ano bang haba nito? So, 25, 25, so that is 50. Okay? Ayan, no? So, kung ito ay 25, therefore ito 25. So, nilagay mo sa kabila. So, ito 25 lang din. Okay? So, I hope we're clear on that. 50 over 3. Maliwanag? So, pindutin lang natin sa ALQ kung ano yung equivalent value niyan. So, that is equals lang sa, sorry. So, pi times 25 divided by 2 and then plus 50 divided by 3. Or that is 55.9366. 55.9366. So, this is in mm. Alright. So, since meron na tayong value nito, ds over dt, pwede na nating ma-compute yung angle of twist ng tube. Ba't ba ito ay may dt? ds over t lang to. Okay? So, to solve for theta, substitute lang natin. So, theta is equals to, again, given naman yung torque natin, the one we solved for number 1. So, isulat ko na lang dito, 157.0. Ito lang ha. 157.079.63. What's my problem? 327 times the length of the tube, which is 1.2 meters. So, magiging 1,200 na siya kasi naka-mm. I-multiply ko na ng 1,000. Over 4 times the modulus of rigidity na 28 gigapascal. So, to make it in megapascal, magiging 28 times 10 to the 3. Tama? So, 28 times 1,000 or times 10 to the 3. Times A sub O, from which yung A sub O nga natin is ito, AO squared. So, pi times 25 squared. So, since kalahati nga lang yan, so divided by 2. And then ito, naka-squared pa. And then multiply yung ds, integral of ds over t. Or that is, ito yung compute natin kanina. 55.9366. And then again, ang makukuha kasi natin dito is naka-radian. So, i-multiply na natin ng 180 para ang sagot natin is in terms of theta. 180 over pi. Okay? Again, ang default unit nito is in radian. So, kaya kung minultiply ng 180 degrees over pi, para yung theta na makukuha natin dito is in terms of degrees. Okay, so pindutin lang po natin sa ALQ 157,079.6327 times 1,200. So divided by 4, divided by 28 times 10 to the 3. Then divided by, quantify ko lang, pi times 25 squared divided by 2 and close parenthesis squared. And then times 55.9366 and then times 180 divided by pi. So what is the answer? So the answer is 5.5963. 5.5963. Okay, so guys, that's it. That's the answer for number 2. So madali lang as long as you know the formula, ayan, direct substitution lang naman siya. And then knowing, basta alam mo yung mga yung bawat variable do sa given equation kung ano yun. For example, ito, area enclosed mula do sa gitna ng iyong tube. So ang kino-consider laging radius is from the center point hanggang dito sa gitna ng iyong thickness. So ito yung enclosed. And then when we talk about S, so yan yung median line o perimeter lang. Perimeter nitong ina-enclose nung area enclosed. Okay? So again, I'll give you 3 minutes to copy. You may start copying the solution. Mhm. Okay guys, so let's proceed with the next topic under the module na torsion.